Okay, module 6.1, slope-intercept form. So up to this point, we've learned a few ways of graphing linear equations. One of them was just by creating a table of values and plugging in random domain values to find your range. And the other way was, and this was especially true if we had an equation written in standard form, would be to find the x-intercepts, right? Which x-intercept would mean that your y would be 0, so x-intercept would just be ax equals c. And to find your y-intercept, when an equation was written in standard form, your y-intercept would mean that x was 0, so that would be by equals c. And then once we got those 2 points, we just plotted them on a coordinate plane, and we connected them with a line, a linear equation, a linear graph. Today, we're going to learn how to graph using slope-intercept form, and we've talked about this a little bit in class already, and I've already shown you the slope-intercept formula, or the slope-intercept form of a linear equation. And this is actually the easier way of graphing a linear equation, so let's take a look. So first, what is the slope-intercept formula? And we've gone over this in class many times already, but the slope-intercept formula, the slope-intercept form of a linear equation is y equals mx plus b, okay? Where m, right here, if you remember from last week, m is the slope. And what is slope? Slope is rise over run. Remember that from last week, rise over run, or change in y over change in x. Okay, so, and we're going to talk about slope a bit more in just a moment. And b, what is b? Well, if we think back to our lesson on arithmetic sequences, hopefully you can kind of figure out what b is. So with arithmetic sequences specifically, when we're writing explicit formulas, that would be your f of 0, yeah? And f of 0 would be your range value when x equaled 0. So hopefully that makes sense to you, that your b would mean that that's your y-intercept, right? Because if x is 0, and remember that is your f of 0 term when we were writing explicit formulas, if x is 0, well, anytime x is 0, we're going to have our y-intercept. And that's just the definition of a y-intercept, which we learned last week. When x is 0, we have our y-intercept. That's where the graph crosses the y-axis. So what is b going to mean when we're dealing with slope-intercept form? B is going to be your y-intercept. Okay, and we've discussed this already in the past, so hopefully this is mostly just a review. Let's move on. So just remember what your slope-intercept form of an equation is, which is y equals mx plus b. And if you're given a slope and if you are given a y-intercept, hopefully you would know how to make an equation out of it. So for example, number 5 in your notes, if we have a slope of 1/4 and a y-intercept of 0, how would we make an equation out of that? Well, we would just plug it in. Remember, m means slope and b means your y-intercept. So if we know our slope is 1/4, it would just be y equals 1/4 times x, and then our y-intercept for number 5 would be 0, so it would be plus 0. You don't really have to write plus 0. It could just be y equals 1/4 x. But remember this, because when we start graphing using slope-intercept form, we're going to get an example that looks like this. But remember, this just means plus 0, so our y-intercept would be 0. We do, in fact, have a y-intercept. It would be at 0. Whereas number 6, again, we would just plug in. So it would be y equals, our slope is -5/2 times x. And then our y-intercept is -3, so I'm going to go ahead and put -3 because of the fact that the y-intercept is negative, and if I would have put plus a -3, that just means -3. What about given a graph? How would we write an equation in slope-intercept form given a graph? Well, we need to figure out, remember, slope-intercept form is y equals mx plus b. Y equals mx plus b. So we need our slope and our y-intercept in order to write an equation in slope-intercept form. Well, our y-intercept, we could just look at the graph, and it looks like our y-intercept, the line is intersecting the y-axis at -5. Is that -5? No, it's -4. I'm sorry. So what would our y-intercept be? Our y-intercept would be -4. Okay. And how could we figure out our slope? Well, remember, slope is just rise over run, and you could just do what we did last week. This is obviously going to be a positive slope. You could tell just by the way the graph is moving from left to right. But we're going up 3, we're rising 3, and we're running 1. So what's our slope? 3 over 1, which is just 3. Our slope is 3. So if we're writing an equation in slope-intercept form, it would be y equals m, which is our slope, 3, times x, plus b. Well, b is -4, so I would just put -4. Same with this. So if we look at our y-intercept for number 8, our y-intercept for number 8 looks like it's +7. And if we're looking for our slope, well, you could tell that your slope's going to be negative, I hope, by now, because from left to right we are going towards -infinity on the y-axis. So our slope is going to be negative. But you could also tell, because if you choose this as your first point, you're not going up. You're going down. So your rise is actually going to be -6, right? You're going down 6 spaces. So -6 is actually going to be your rise, and then you're running 1, 2, 3, 4. So your slope is going to be -6/4, which is, if you simplify that, that would be -3/2. So what would your equation be in slope-intercept form? It would just be y equals m, which is our slope, -3/2, x plus b being our y-intercept, and we just found our y-intercept to be 7. So before we get into graphing using slope-intercept form, I really need you to have a firm grasp and a firm understanding of what slope actually is. Remember, slope is that constant rate of change in a linear function, in a linear graph. It's going to be constant, okay? And it's always going to be rise over run, change in y over change in x. So let's say we had 3, right? Let's say I told you that our slope was 3. What does this mean? Well, slope is supposed to be rise over run, right? So what does it mean when we just have 3? Okay, normally we think of slope as a fraction. Well, 3 we could turn into a fraction, right? 3 is just 3 over 1. So what would this mean? Remember, slope is rise over run. So what would this mean if we were using slope to graph? That means we would be rising 3 and running 1. Okay, rising 3 and running 1 on our graph, starting from a set point. Okay, but I also need you to realize that that if I were to put a negative in front of this 3, right, and a negative in front of this 1, did I really change the slope? Not really, because this is still going to be positive. A negative and a negative is automatically going to turn into a positive, so I'm not really changing the slope. So in reality, we could go up 3 and to the right 1, rise over run, or if we have 2 negatives here, we could go down 3 and to the left 1. And that's really the same slope. And if you look at this, I'll do this with a different color here, but if you look at this, it kind of forms a line here that looks kind of like a line of a linear function that has a positive slope, which this does have a positive slope. So you could also do this backwards if you just realize that, hey, if we have a negative in our numerator and our denominator, that's going to mean positive. And what about this fraction here, -3/5? Okay, well, you need to remember that the negative is only going to be attached to one of these terms, right? It can't be attached to both. If it's attached to both, then we get this situation right here, and that will mean that your slope is positive, and this is obviously not positive. So you could either put the negative with the numerator, which would symbolize your rise, or you could put it with your denominator, which would symbolize your run. And either way, in fact, let's go ahead and do that. So if we have the negative with the rise, that means we'd be going down 3, right, and to the right 5, because our Our run is 5. But if I put the negative here, okay, what's happening? I'm going to use blue for this. So now our rise is positive 3, so we're going up 3. And this time our run is negative, so we're going to go to the left. And if you see, that's kind of the exact opposite of what we did before, which forms that line with that negative slope. Okay, and you need to know how to do it both ways, whether we have a positive slope or a negative slope. You need to know how to do it both ways because that's the best way to graph these, and you're going to need to know how to do that, and you'll see why in just a few moments with some examples. So now we're going to use slope-intercept form to create a line to graph a linear function. So how do we do that? First, remember slope-intercept form is y equals mx plus b, and I'll write that up here. So when you're using slope-intercept form to graph a linear function, you first want to identify, well, what's our slope? What's our y-intercept? So if an equation isn't in slope-intercept form, you're going to want to put it in slope-intercept form. Luckily, number 3 is already in slope-intercept form. So what is our slope? 2/5. Remember, slope stands for rise over run. That means we are rising 2, running 5. What's our y-intercept? 2. Y-intercept is where we cross the y-axis. So I could already put a coordinate point on 2 because I know I'm crossing the y-axis at 2. And from there, I can get an unlimited amount of points just by using my slope. So my slope is 2/5, so I know I'm going to rise 2 and run 1, 2, 3, 4, 5. And that right there will give me another point. Okay? But look, this is where it comes in handy knowing how to do this both ways, because if you look, I ran out of space. So if I wanted to get more points, I wouldn't be able to do it with the way that I currently have my slope. But you also need to remember, and I'll do this in green, that we could also say, well, the slope is also -2 over -5, right? Because a negative and a negative, that would still be a positive. So if we do that, that means we could start at this point again, but this time we're going to go down 2 and to the left 5. Okay? And there we have another point. So you need to know how to do this both ways. You need to know how to graph using slope both ways. And then all we'd have to do, because we don't have a constraint, we don't have a set domain, we could just connect this with a line, because this will be continuous, just like that. And that's how easy it is to graph using slope-intercept form. Let's do another example. So here we have y equals -4x. And remember, slope-intercept form is y equals mx plus b. So you might be wondering, well, where is b? So this is a good one for you to remember, that y equals -4x. I could go ahead and add something to this, and I wouldn't be really changing this equation. And we did this in one of our previous slides. So really, I could go ahead and put +0, right? And am I really changing this equation? Absolutely not, because -4x plus 0 is still -4x. But now I have my b, and now I have my y-intercept. So my slope would be -4 over 1, and my y-intercept would be 0. And remember, slope is rise over run. Okay? And I could also write my slope as 4 over -1. It wouldn't matter. But remember, when you have a negative fraction, the negative is either going to be in the numerator or the denominator. Can't be in both. If not, it's going to be a positive. Okay? So now we're going to start at our y-intercept, which our y-intercept is 0. So we're going to put a point right at 0. And then, well, our rise, if we're using this first one, which I'm going to do in red, is -4. So we're going to go down 1, 2, 3, 4. And then our run is 1. So our point would be right here. But if we do it using this slope, this time our rise would be +4. So we'd go up 1, 2, 3, 4. And our run would be -1. So our ordered pair would be right here. And you need to know how to do it both ways. Make sure you know how to do it both ways. Then this will be continuous. So we would just go ahead and draw as straight a line as possible. And that would be your linear function, and that would be your graph. Okay, so I want you to take a look at this one, because we already know quite a few ways of graphing linear functions, tables using intercepts, and now slope-intercept form. So if we look at this one's actually going to be easier to use to graph using intercepts, right? Because if we set y to be 0 and we look for our x-intercept, 20 is divisible by 2, right? And if we set x to be 0 and we're looking for our y-intercept, well, 20 is also divisible by -4. So it's really important for you to identify and really understand which method would actually be easier. So in this case, I'm not going to use slope-intercept form. What I'm going to do is I'm just going to find my x and my y-intercept, right? So I'll do my x-intercept in blue. For my x-intercept, that means y has to be 0. So that would just be 2x equals 20. So what's my x-intercept? Well, it's going to be 10, or 10 comma 0. Okay, and for my y-intercept, I'll do that in red. That's just going to mean that the x is going to be 0. So that's -4y equals 20. So my y-intercept would just be -5, or 0 comma -5. So in this case, it's a lot easier to just find our intercepts than to use slope-intercept form, which if we were to use slope-intercept form, we would have to go ahead and solve for y anyways. So it would be a lot easier just to leave it in standard form and find our intercepts. So unfortunately, I don't think my graph goes to 10. We could just go ahead and extend the graph. There we go. So my x-intercept would be at 10, 0, which is right here. Then my y-intercept would be at 0, -5, which is right here. And then you just make your line. So in this case, it'd be a lot easier just to use your intercepts. So here, it wouldn't be easier to use intercepts, right? Because if you look at your x or your y-intercept, right? I'm sorry, your x-intercept, where you'd have to set y to be 0. Well, 21 isn't divisible by 4, right? So it might be easier just to try to do this one using slope-intercept form. Now, slope-intercept form is y equals mx plus b. So this is obviously not in that form yet. So we're going to have to change it so that it is in that form, y equals mx plus b. So how would we do that? Well, we want to get y by itself. So we're going to subtract by 4x first. And I like putting the x first. It wouldn't matter if you don't do it this way, but I like having my x first. It would be -4x plus 21. And then y needs to be by itself, so we'll go ahead and divide everything by 3. And if we do that, we get y equals -4 thirds x, and then 21 divided by 3 would be 7, so it would be plus 7. Okay, and now it's in slope-intercept form, so now we could identify our slope, which would be -4 thirds, and we could identify our y-intercept, which is 7. Remember, our slope can also be 4 over -3 as well, so we could either go down 4, because remember, slope is rise over run, or we could go to the left 3, but we can't do both. All right, so first let's go ahead and put our y-intercept, which is 7. And in this case, I'm definitely not going to use this one right here because I wouldn't be able to go up 4 from 7. So I'm just going to go ahead and use this slope, and I'm going to have my rise be negative. So if my rise is negative, that means I am going to go down 4, 1, 2, 3, 4, and I'm going to run 3, 1, 2, 3. And if I do that, get my point right over here. Let's do it one more time. So 1, 2, 3, 4, and then 1, 2, 3, and I get my point, which is right here. And then we could go ahead and plot our line. Mine isn't that straight, but try to make yours a little bit more straight than mine. So quickly, I want to do 2 more examples with you. I know this video is already pretty long, but I want to do 2 more examples for you. Here we have y equals -2. So what would y equals -2 be? Well, obviously, y equals mx plus b. We have no m. We have no x. So what would this look like? Well, we're going to just go ahead and forget about slope-intercept form for now and just think of tables. So if we were to put this on the table, it's y equals -2. right? Y is always going to be negative 2. So regardless what your x is, y is always going to be negative 2, negative 2, negative 2. Wouldn't matter what your x is, right? So your x could be 1. What would y be? Negative 2. Your x could be 3. What would y be? Negative 2. Your x could be negative 1. What would y be? Negative 2. Your x could be negative 3. What would y be? Negative 2. So what would this graph look like? It would actually be a horizontal line at negative 2. Okay? So anytime you have y equals a constant, anytime you have y equals a constant, it's going to be a horizontal line. Write that in your notes. That's important. And I hope that makes sense, because if you look at this and you find the slope, right, it doesn't matter what your x is. If you find our slope, remember slope is change in y over change in x, right? What would your change in y be? It would be nothing. It would be 0. So it wouldn't matter what our change in x is. This we already know is a 0 slope. And we already know that 0 slope is going to be that horizontal line. I hope you could kind of figure out what this would be. So if we do our table, this time all of our x's are 4, 4, 4, 4. So it wouldn't matter what y is, right? So y could be 1. What's our x going to be? 4. Y could be 2. What's our x going to be? 4. Y could be negative 1. What's our x going to be? 4. Y could be negative 2. What's our x going to be? 4. So this is actually going to be a vertical line. And I hope that makes sense to you, because remember, what is slope? Slope is rise, change in y, over run, change in x. Now, if we look at our change in x, what's our change in x? It's 0. So it wouldn't matter what our change in y is. If we have a 0 in the denominator position, we always know that this is going to be undefined. And when it's undefined, we get that vertical line. Okay? So that's it. We're going to go over more of these in class tomorrow. But hopefully this was helpful. And I will see you tomorrow. I'm sorry, one more thing. So in your notes, just make a note that anytime it's x equals a constant, it's going to be a vertical line. Okay, that's the last thing I want to say.